All right, let us finish up target 41. All right, this is the problem we left off on. I kind of kept the graph there, but I erased the work we talked about. We had a couple ways you can do it as far as find this whole area here, subtract off this area, or find this whole area here, subtract off this area. I'm going to talk about a couple different ways you can do it in addition to those two. What I like to do, and it's just me, your ways were definitely correct. No reason not to do it those ways, but my way, another way, just in case you want options, is I'll split it. Because there's different bottoms on this half and this half, I'll split it and write two integrals with those two different bottoms. So I'll write my first integral from 0 to 2, because those are my x values, and the top is the square root of x. The bottom is y equals 0, so I don't need to subtract off 0. And then I'll add on from 2 to 4. The top is still the square root of x, but my bottom is now x minus 2. Make sure you group your x minus 2. And we'll throw that into the calculator, and we'll get the same thing. So we'll integrate from 0 to 2, the square root of x, with respect to x, and we'll add on the integral from 2 to 4 of the square root of x minus x minus 2 with respect to x, and you'll get 10/3. The other way's got 10/3 as well, which, if you want an estimate, is 3.333333. Okay? A fourth way to look at it is to take this shape, and instead of, we've been looking at it like this with respect to x. Instead of doing that, we can solve everything for x. So this would be x equals y squared, and this would be x equals y plus 2. Solve it for x, and then we can look at it in terms of y. Advantage of doing here is I don't need a split integral. I don't need to take a whole minus a part. I can just integrate it. Now I'm looking at the y values now, from 0 to 2. And our top function is, if this is our y-axis, our top function is a positive one furthest away from here, y plus 2, minus our bottom function would be y squared. And now, because we looked at it this way, stacked along the y-axis, it would be dy. And if we look at it that way, we'll integrate from 0 to 2, y plus 2 minus y squared with respect to y, and we get the same thing. So there's another way to look at it. You can turn it sideways, solve it for x, and do it with respect to y, meaning y is the variable. Sometimes that makes problems a whole lot easier. In this case, it was a little easier. We didn't have to split it into different integrals, or we didn't have to subtract off. I would say on this one it made it a little easier. And that leads us to integrating with respect to y. Sometimes it's easier to go sideways instead of up and down, in which case you're doing it with respect to y instead of with respect to x. So anytime you're stacking them sideways, like in these drawings, you are dy. And then just remember the one farthest to the right is the upper one, because you want to be the biggest positive number for your top and your lowest positive or lowest negative for your bottom. All right? And this one we've already done. We've done it both ways. We did it with respect to y and with respect to x leading into this. So we're going to skip this slide. We'll go to slide 12. Find the area enclosed by the graphs of y equals x cubed and x equals y squared minus 2. Now, this one starts out as a little bit of a nightmare because one is in terms of x and the other is in terms of y. What I like to do on this one is get them all in terms of the same variable right away. So I will take, this one's easier to solve because it's an odd power. An even power, you got to worry about plus or minus. So you'd have two equations to solve there. So I'm just going to solve this one for x. X equals the cube root of y. And now as I graph it, I'm going to graph it like I normally do. In terms, I'm going to go y equals, I'm just going to switch the variables. So this will be y equals the cube root of x, and this will be y equals x squared minus 2. It'll look flipped from where it should be, but who's to say we can't use the axes however we want? So we'll graph this as y equals the cube root of x. And then we'll graph y equals x squared minus 2. Right, and we're looking for this section right here. My F1 is on top. My F2 is on bottom. And we'll find our intersection. Intersection is negative 1, 1 there. My other intersection is 1.79, excuse me, 1.21. So we'll store that one into A. I'm a little curious about this one because this one didn't work out. This one did, so I'm going to store that one anyway. Store that into B. And so when we integrate, we'll integrate from B to A. And then our top function was the blue function, which is F1. So we'll do F1 of x, or type in the actual function, minus F2 of x, with respect to x. Get 4.2149 is our area for that one. All right. So because this was easy to solve, and then we got x equals and x equals, we can solve for x first and treat this as our y-axis and that as our x-axis, and it works the same because they're variables. We can use them however we want. We don't have to keep them the way they do them, just as long as we remember the switch. Okay, find the area of the region, example 4. And again, this is the one we did back here. Same question, square root of x and x minus 2. And we caught a couple different ways to do it, using subregions, where you split it up into regions. I split it. You guys did the full thing and subtracted off pieces. Good strategies there. All right. So in conclusion, how do you find the area between curves? It's pretty basic. Find the area under the top minus the area under the bottom. All right. Any questions? See me in class tomorrow.